For today's lesson, we're talking about solving simple trigonometric equations. Now, for this, we're going to be using our unit circle. So if you don't have that out already, you might want to pull that out real quick. You can also use the table and reference angles, but it'll be a little bit harder to kind of go through stuff if you have that. And we want you to be able to start using the unit circle a little bit more. So I would prefer you have your unit circle out and looking at it, okay? So for these, what we're trying to do is we're trying to find solutions to the given equations in between 0 degrees to 360 degrees, okay? Now notice in my range over here that I have from 0 is included, but 360 is not. So because 0 is at the same spot as 360, so it kind of keeps it as a function in that sense. So if I'm looking for sine theta equals square root of 3 over 2, this question is asking you for what angles for sine give you the ratio of square root of 3 over 2, okay? So if I was to draw my unit circle here, okay, sorry for the poor circle, I know that sine, from all of our other discussions, sine should be attached to y, right? And on the unit circle, where sine is positive in the first and the second quadrants, because y is positive in those quadrants, right? Because it's above the x-axis. So my answers, or I might have two answers on this one, because there's two places where I could get square root of 3 over 2. So looking in the first quadrant and looking at your unit circle, hopefully you notice that at 60 degrees, you have the ordered pair of 1/2 comma square root of 3 over 2, right? So that's one instance where y, or your theta of 60 degrees gets you that square root of 3 over 2 for sine. So that's one of your answers right there. Okay? Now, looking over on the other side, I would hope you notice for 120, you get negative 1/2 comma square root of 3 over 2. So you also get square root of 3 over 2. So then at 120, it's also an answer. And because these are the only two places you're ever going to get square root of 3 over 2 for sine, then those are your answers. And it's that simple, okay? So there's not going to be a lot of work. You can make the drawings if you want, but there really isn't any work to show for these. So this will be a quick lesson for you. I'm going to show work because I need to describe, because you can't see my unit circle, so I'm going to kind of show you what I'm looking at for these other examples, okay? So let's go through a couple more, because they're a little bit harder than that and not as straightforward. So tangent of theta equals negative 1. So on our unit circle, now tangent is not something you can see straight up forward, because it is going to be y over your x, or like we've said in class or in the other videos, it'd be the sine over the cosine. So if we know that sine is y, we know cosine is x. So we need to find a ordered pair that when you divide them, you would be able to get 1. That's what's happening here for tangent. Now, where tangent is negative is in the second and in the fourth. So I'm not going to worry about the first, and I'm not going to worry about the third, okay? Because they're positive there. So in the fourth, or in the second, let's start there. The only ordered pair that you can see on there that's like exactly the same ratio for each other are the fourths. So if you look at 135 degrees, it'd be negative square root of 2 over 2, comma square root of 2 over 2. And when I say force, if you're looking at the radians, it has the force on it. That's what I mean by that. And then in the fourth quadrant, if you go to there, that one would be 315. That gets you square root of 2 over 2, comma negative square root of 2 over 2. Okay? So looking at these, however you orient them, so for tangent of 135, you are taking the square root of 2 over 2 divided by the negative square root of 2 over 2, and then multiplying by the reciprocal. So there, they cancel, leaving you with negative 1. So that's how I get negative 1 on the first one. And then I would get the same thing for the fourth quadrant one for 315, but just the signs are different. So your two answers would be 135 and 315. Okay, a couple more. So secant of theta is equal to negative square root of 2. So for that one, you want to kind of figure out, okay, where can I get a square root of 2 in my stuff? So the only places, once again, are like those 45 degree angle ones, or the pi over 4s. So same idea, but now, because secant is like cosine, where it's 1 over x, so it's like the reciprocal kind of thing. So it's only talking about the x, so x is negative in the second quadrant and in the third quadrant, okay? So I'm not going to worry about the first, I'm not going to worry about the fourth. So going to, let's go to 135 first. So we've already kind of looked at this one. So if I've looked at this terminal point here, and I take out the x because that's all I want for secant, I get something that looks like that, right? So then here I would need to do the reciprocal. So that flips it around. Now you're probably saying, okay, well, those still don't look like each other. But if you were to rationalize the tops and bottom, that gets you 2 square root of 2 over negative 2, which those reduce. So then that gives you negative square root of 2. So voila, we got the same ratio. Same thing happens in the third quadrant. So this ordered pair, you still have a negative square root of 2 over 2 for your x. So the same thing happens in that one's 225. Okay, so then these are your two answers. So 135 and 225. Okay, and the last one. So cotangent of theta equals square root of 3 over 3. Now here, you want to be able to use the same idea as what we did for tangent, where it's like one value divided by another value, but here it's flipped. So for cotangent, it'd be x over y instead. So I'm looking on the unit circle for values that give me a positive ratio for cotangent and tangent, because they're kind of the same. So that would be the first quadrant, and that would be the third. Remember, in the third, everything's negative. So x and y are both negative, so if I divide them, that makes them positive. So the second and the fourth are a no-go here. So here, now I want to think about square root of 3s. Where do I have those? So So there's two places where you're going to get a square root of 3. Oop. So either 30 degrees or 60 degrees, right? Okay. Now, because you're looking at these two with the square root of 3's, just remember that you just need to kind of guess and kind of play around here and figure out which one's going to get you what you want if you don't have that table with you that we've already written down. Because if it's not one, it's the other. Okay? So you have a 50-50 chance. If you show your work for one, then you're just showing that the other one's the correct one if this one's not. Okay? So I'm going to go with 30 degrees here. See what happens. So I take 1/2. And then divide it by square root of 3 over 2. Okay? Means I multiply by the reciprocal. Those go away. I'm left with 1 over square root of 3. If I rationalize that, that gets me square root of 3 over 3. I got what I wanted. I chose correctly. If I would have picked 60, that would have said it was square root of 3. Obviously not, so it has to be 30. Okay? That would have been the kind of thought process I would have had. So if 30 degrees is the one that I want, then the one on the complete other side is going to be the other one that gives me what I want. So because it's the ratio over there is negative square root of 3 over 2, comma negative 1/2. So it's in the same order as 30 degrees is for 210. So those would be my two answers, 30 and 210. Okay, so hopefully that kind of makes sense how I'm going through that. I'm just using the unit circle to help me out here. And for you guys, it would be easier. You don't have to draw the circles. You already have them on the unit circle. So the only math you would have to do is to like make sure that you have the correct ratio by like the work that I had on the right side of these problems. Okay? Have fun.